if you wanted to take a look at a couple additional examples, I'm going to do those here. Now, one of the things that will come up in these examples is flipping something, flipping a factor, and how we do that with -1. So let's go ahead and get started. Again, we're dividing, so we keep our numerator, our first fraction as it is, and then we flip our second fraction. So I'm going to just highlight the second fraction here. And when we rewrite this, we'll leave our first fraction, k over 3, or k minus 3 over k plus 1 as is, and then flip the second fraction. Now we have something that we are multiplying instead of dividing. At this point, we need to do our factoring step. So we have a couple things. Both of the highlighted terms are factorable. So let's go ahead and do that. A 1 minus k squared, or you might recognize that as 1 squared minus k squared, is a difference of squares. So let's factor that as 1 minus k and 1 plus k. So we get 1 minus k, 1 plus k. And on the bottom here, k squared minus 4k plus 3, two numbers that add to 3 and multiply to 3 and add to -4, going to be -3 and a -1. -3, -1, and we have a k minus 1, a k minus 3. Wrap these in parentheses here. And so now let's go ahead and rewrite this equation with the new factors. We see our 1 minus k, our 1 plus k, replacing what we had here, and then our k minus 3, k minus 1 factors replacing what we had here. At this point, we want to do our canceling. However, we have a little bit of an issue. We have the k minus 3 and the k minus 3 that can cancel, but everything else is close but not quite there. We have a 1 minus k at k minus 1, a k plus 1, and a 1 plus k. Well, in the case of the k plus 1 and the 1 plus k, we know that we can flip the order of terms without really changing the equation when it's addition. We can change the terms. However, we cannot do that in subtraction. A little no there, just so we remember. We cannot just flip them willy-nilly in subtraction. However, what you could do is a little trick. If you multiply the entire part of this by -1, you could turn that 1 into a -1, turn that negative k into a positive k, and flip it. So I'm going to show you what that looks like real quick. Pull this away. Up on top, get rid of that highlighting for now so that we can focus on something else. We have this 1 minus k. Down here, I replace that with a -1 times k minus 1. If you think about what we're doing, -1 times k is negative k. -1 times -1 is positive 1. So effectively, when I distribute this, we go back to where we started. So this is a valid thing to do, to replace what we have up here with what we have down here. And again, as we mentioned before, the 1 minus k, the 1 plus k and the k plus 1 are in fact the same, so these are okay to switch between without making any additional changes. Everything else should be able to stay the same. Now we can actually start canceling. We had our k minus 3 that we noticed earlier. We also have the k plus 1 situation that we can cross out. And we have a k minus 1 now that we can get rid of. So after all of that, we're left with nothing but a -1. And that's going to be our final answer. So let's practice this one more time. This example, like one of the earlier ones, is a compound fraction. So we have a fraction within a fraction. The way that we do that is we take the 1 in the denominator and we flip it upside down to multiply. So if we pull this away here, our original x squared goes right here in our numerator where it should be. 9x squared minus 4y squared goes in our denominator as we would expect. And then our x cubed, originally in the numerator, goes to the denominator because we flipped the bottom fraction. Same thing here, the 2y minus 3x that was previously in the denominator down here goes up to its numerator. So once we have flipped the fraction, we are multiplying, and now we can simplify this a little bit quicker. Now let's see where we can do some factoring. It looks like the x squared term and this 2y minus 3x term are as factored as they can be. The x cubed is as factored as it can be, but this 9x squared minus 4y squared could use some work. Now, if I were to rewrite this, I would rewrite this as 3x quantity squared, because 3 squared is 9, x squared is x squared, minus, and then 2y squared, that whole quantity. So the 2 squared gets us our 4, the y squared gets us our y squared. So what can this factor into? Well, we have a difference of squares now. So if we have a difference of squares, it's going to be a 3x plus 2y and a 3x minus 2y. So let's write that out. 3x plus 2y and 3x minus 2y. So then we can cancel that, cancel that. So that it's rewritten below here. Ooh, we have one of those situations where we can almost cancel something. We have a 2y minus 3x and we have a 3x minus 2y. Let's apply our -1 trick. So let's pick one, let's pick our numerator, and apply that -1 trick. We're going to have the 2y minus 3x here. If we multiply each of those terms by -1, we can effectively switch what we have. So I'm just going to do that real quick right here just so you can see that. We would have a -2y plus 3x, and then of course we can switch the order of addition, which is why we can write it like this. That's 3x minus 2y. Because we did change it, because we multiplied by -1, we have to undo that and multiply by -1 again to get back to where we started, so that we're not actually changing the equation. Once we have that, we just rewrite our denominator the way we had it before, no changes there. And then we go to our cancel. Well, we have our 3x minus 2y and our 3x minus 2y, those cancel out nicely. We have an x squared on top and an x cubed on bottom, so we have one more x on the bottom than we do on the top. So we'll get rid of the numerator part, and we'll just turn this into x to the first power down below. And cancel, get rid of that just so that we don't confuse ourselves. We're left with a -1 on top. We're left with 3x plus 2y, that quantity all times x in the denominator. So we rewrite that cleanly, and that is our final answer.